Hi Math 30s. So this video we're going to be working through lesson 5, and lesson 5 is going to be tying everything together with the unit circle and then how would we apply the unit circle. This video that I'll be making, it is under the assumption that you have already generated your unit circle. So I've made a video on how to completely generate the unit circle using degrees, using radians, and then figuring out all of the points. So again, this video is just assuming that you have this knowledge. I'm going to recommend that you have a unit circle with you for this, for these questions that you'll want to be able to draw from. And then remember that on a test, you would have to completely generate the unit circle in order to answer these questions. But for going through the class examples, I will keep referring to this slide here. Okay, I want you to flip to the bottom of page 532. And we're going to talk about the sine ratio, the cosine ratio, and the tangent ratio before we get into the class examples. In a different lesson, I think it was lesson 3, I gave you the sine ratio, the cosine ratio, and the tangent ratio. And what I told you to sort of memorize that the sine ratio, sine is 7 yellow rabbits. When we're applying this to the unit circle though, our radius on the unit circle is always going to be 1, right? So when I say, well, what's the sine ratio when we're dealing with the unit circle, it's going to be whatever our y coordinate is over 1, which is basically just y. So on the unit circle, when we have a coordinate, and I say what's the sine of that coordinate, you are just going to be looking at the y value. And I'll give you an example once we finish these. The cosine ratio, if sine is y over r, cosine is x over r, that would be x over 1 on the unit circle, and that would just simply be x. The tan ratio, tan is going to be y over x. Okay, so here's what I mean. Let's say I said to you, locate pi over 6. So on the unit circle, this would be pi over 6, and from our circle, here is pi over 6, and here's our coordinates, root 3 over 2 and 1/2. So let's write the coordinates for pi over 6. So pi over 6 is root 3 over 2 and 1/2. If I asked you, what is the sine of pi over 6, you have to simply remember that sine is y. So sine of pi over 6 is the y coordinate, which is 1 over 2. If I said, what is the cosine of pi over 6? The cosine of pi over 6, cosine is always going to be the x coordinate. So the cosine of pi over 6 is going to be root 3 over 2. And then the one that you have to work a little bit for is the tan of pi over 6. So if I said, okay, well, what's the tan of pi over 6? Tan is y over x. So normally we would say y is 1 over 2 divided by root 3 over 2. So that would be the tan. But because remember, often these questions you're going to be doing without a calculator, the tan of pi over 6 is 1 over 2. Instead of division, we're going to multiply by the reciprocal, by 2 over root 3. And then what you would get, 2 over 2 would cancel, and we would get 1 over root 3. So the tan of pi over 6 is 1 over root 3. You would never leave that as your final answer, though, because you would need to rationalize the denominator. So you need to multiply both numerator and denominator by root 3. And you would get the tan of pi over 6 is equal to root 3 over 3. So I will often tell students on the unit circle to go around, and you could say for everything, put a C above your X coordinates, put a Y above, or not a Y, a S above your Y coordinates. So all of your X's would be your cosine ratios, and all of your Y's are your sines. Okay, let's apply this. And where we're going to apply this is class example 1. So the sine, cosine, and tangent of 300 degrees. And what it's going to say on a test or a diploma is it's going to say the exact value. So the exact value means that we could not type this into our calculator, because if I type in the sine of 300 degrees, so the sine of 300 degrees, I get an irrational number. What is the exact value of this? So in order to do that, what you have to do is you have to go to your unit circle and you have to say, okay, 300 degrees is right here. And 300 degrees, the coordinate is 1 over 2 negative root 3 over 2. So let's jot that down. Sine of 300 degrees is 1 over 2 and negative root 3 over 2. So that is what 300 degrees is. What you need to remember is that the x is always your cosine, the y is always your sine, and then tangent is going to be this divided by this, which is the y times the reciprocal of the x. So sine of 300 degrees, I just look and I say, what's my y coordinate? My y coordinate is negative root 3 over 2. And that is the exact answer. We typed in our calculator the sine of 300 degrees and we got this. Now let's type in that negative root 3 over 2 and see if we get the exact same answer. So negative root 3 divided by 2, and we get that exact same answer. The cosine of 300 degrees will do next. So the cosine of 300 degrees is the x coordinate, which is 1 over 2. The tan of 300 degrees is equal to y over x. So that would be negative root 3 over 2 times the reciprocal of your x coordinate, which is 2 over 1. Your 2's would cancel, and the tan of 300 degrees is equal to negative root 3. Okay, the cosecant of 300 degrees. So cosecant is the reciprocal of sine. If sine of 300 is this exact value here, if that's sine of 300, the cosecant is going to be the reciprocal of that. So the cosecant will simply be 2 over root 3. I'm actually going to put my negative up here. And the reason why I'm going to put my negative up there is because I need to rationalize the denominator. So I need to get rid of the radical in the denominator. So I'm going to multiply both numerator and denominator by root 3. The cosecant of 300 degrees is equal to negative 2 root 3 over 3. The secant of 300, secant is the reciprocal trig ratio for cos. If the cos of 300 is 1 over 2, the reciprocal of that is 2 over 1, which is simply just 2. The tan of 300 degrees is negative root 3 over 1. So the cotan is going to be the reciprocal. So that's going to be 1 over root 3. I'm going to put my negative up here because I need to rationalize the denominator. So I'm going to times this by root 3, and I'm going to times this by root 3. And the cotan of 300 degrees is equal to negative root 3 over 3. All right, cosine of 3 pi over 4. So if I wanted to find this really quickly, remember that's our 45 degree angles, and I'm counting to 3. So that's pi over 4, 2 pi over 4, 3 pi over 4. So this is where 3 pi over 4 is. You need to have your unit circle, and your unit circle for 3 pi over 4, we're right here. Cosine is the x coordinate, so negative root 2 over 2. Okay, the cotan of 5 pi over 3. So you're going to say to yourself, well, cotan of 5 pi over 3, I'm not quite sure of, but I know that cotan is the reciprocal trig ratio for tan. So the tan of 5 pi over 3. So the tan of 5 pi over 3 I could find. 5 pi over 3, that's equivalent to 10 pi over 6. So on our unit circle, let's find where 10 pi over 6 is. So 10 pi over 6, which is 5 pi over 3, is right here. And then the tan of this would be y divided by x. So negative root 3 over 2 times the reciprocal of this. So negative root 3 over 2 times 2 over 1. The tan of 5 pi over 3 is negative root 3 over 1. You would just say negative root 3. Once you have what the tan of that of 5 pi over 3 is, the cotan is simply the reciprocal. So the cotan would be 1 over, negative 1 over root 3, and then we have to rationalize. So the cotan would be negative root 3 over 3. Okay, next question. Let's do the tan of 600 degrees. So we always want to be dealing with our principal angle. So we want to have our smallest positive rotational angle. So tan of 600 is going to be the same as, if I subtract 360 from this, that would give me the tan of 600 minus 360 is 240. So you need to go to your unit circle and you need to locate where 240 degrees is. So 240 degrees is right here. The tan of this is negative root 3 over 2 times the reciprocal of the x. So negative root 3 over 2 times negative 2 over 1. Okay, two negatives is going to give you a positive. 2 over 2 will cancel, and the tan of 240 degrees is simply equal to root 3. And that would be your answer. The tan of 600 is going to be equal to the tan of 240, which is going to be equal to square root of 3. Last question is a cosecant of 3 pi. So again, cosecant, think about what that is the reciprocal trig ratio of, and that is the reciprocal trig ratio to the sine of 3 pi. So where 3 pi is, halfway around your unit circle is pi, so that would be pi. And then if I keep going, I get to 2 pi. And one more half rotation, this is where 3 pi is located. So I'm going to go 1 pi, 2 pi, 3 pi, and then it would be 4 pi, 5 pi, keeps going on. So 3 pi is right on your axes here. And you say, okay, well, what's the coordinate of that axis? Your x value is negative 1, and your y value is 0. So the sine of 3 pi, if I said what's the sine of 3 pi, we know that the sine is the y value, okay? So that answer would be 0. Now, the cosecant of 3 pi is going to be the reciprocal of this. So if I turn this into a fraction, I would get 0 over 1. The reciprocal of 0 over 1, the cosecant of 3 pi is going to be 1 over 0. You could never divide a number by 0, so this answer is actually going to be undefined. So the cosecant of 3 pi is undefined. Okay, students will often ask me, so when we get to class example number 3, they'll often say, are all of the points going to be either like the 30, the 45, the 60, or on the axes? And the answer is 95% of the questions will be one of these points here. What I'm going to show you though now is on the next class example, we're going to get a point that is not going to be one of these three, and they're going to say it's on the unit circle, and I'll show you how to find that. So on this question here, it's going to say use a calculator. to determine to 4 decimal places the coordinates of the point on the unit circle that corresponds to this rotation here. So first of all, they tell us it's on the unit circle. Okay. Then they give us 2 pi over 5. Now we've learned that we want to get this to either a denominator of 4 or of 6. If we can get it to 4 or to 6, we are going to be one of these nice points on the unit circle. If they give you a question where we can't get to over 4 or over 6, it's going to be a different point on the unit circle. So how we do this is as follows. First thing I'll show you is I'll show you where this would be if we were in degree mode, like if we were in degrees. So let's convert this to degrees first. So 2 pi over 5. If we're converting this to degrees, it'd be 180 degrees over pi. And then from here, we would divide both of these by pi. Let's see what 2/5 times 180 is. So on our calculator, 2 divided by 5 times 180 degrees is going to give me 72 degrees. So 2 pi over 5 is equivalent to 72 degrees. So what that would be on our unit circle, they give us 30, they give us 45, 60. 72 degrees would be right about here on the unit circle. And what they're saying is, well, please tell me what that x value is, and please tell me what that corresponding y value is for this point right here on the unit circle. So how you would do that is as follows. What you have to remember is that you have to remember that on your unit circle, we have coordinates and they're x comma y. You need to just remember that the x coordinate is always your cos and your y coordinate is always your sine. Okay, so if we were to find, well, what is the x value and the y value that corresponds to the rotation of 2 pi over 5, what we are going to do is we're going to say, okay, this would be the cos of 2 pi over 5, and this would be the sine of 2 pi over 5. So then on your calculator, you would need to calculate what the cos of 2 pi over 5 is, and you need to make sure you are in radian mode. So on your calculator, I'm in degree mode. So I need to go to radian mode. And I would need to type in the cos of 2 pi divided by 5. And that answer to 4 decimal places is 0.3090. Do the same thing with sine. Type in on your calculators the sine of 2 pi divided by 5, hit enter, and what you should get is 0.9511. So what that means is a rotation of 2 pi over 5 corresponds to 72 degrees. 72 degrees would be right about here. Let's say if this is 60, 72 would be right about here. The coordinates, the xy coordinates at 72 degrees or at 2 pi over 5 would be 0.3090 would be your x and 0.9511 would be your y. Okay, this question here. I really like this question, class example number 4. It involves a little bit of work to do it. This is a good exam question. This separates the students who could think through this stuff versus who struggles. So what they do is they give you 2 points on the unit circle. So you need to find these 2 points. I know that that's going to be a reference angle of 45 degrees. And if my y is negative, I am going to be in the second quadrant. So if I look at my unit circle, sorry, my y is negative, I would be, where would I be for point P? Y is negative, right here. X is positive, Y is negative. That's 315 degrees or 7 pi over 4. Okay, so you take that first point, you find it on your unit circle, 315 degrees. So what I'm going to do is I'm going to jot down point P is 315 degrees. That corresponds on my unit circle, 315 degrees is 7 pi over 4. And I'm going to put that point in here. this would be point P. And then again, it's at 315 degrees, or 7 pi over 4 would be right here. Then we have to locate point Q. So point Q, x is negative, y is positive. This point would be in quadrant 2. So locate this point in quadrant 2 on your unit circle, and it would be right here at 120 degrees, or 2 pi over 3. So let's record that for that point Q. So 120 degrees, or 2 pi over 3. 120 degrees, or 2 pi over 3. So that point Q is right here. And I know what my degrees in radians are, in radians and in degrees. So then what it says this: if an object rotates counterclockwise from point P to point Q. So you're going to take an object and you're going to go from point P to point Q. What it's saying, what angle did I just rotate through? So what angle did I just go to? So we've got to figure out what this angle is, and that should be very easy. This is a 45-degree angle, right? So down here, this was a 45-degree angle. So from here to here, this is 45 degrees. This is a 90-degree angle, right? So quadrant 1 is 90 degrees. And then you have to say, well, how many degrees was it to get from 90 to point Q? So if you go, point Q is right here, 90 to 120, this was a 30-degree angle. If I was to add those three up, so 45 degrees plus 90 degrees plus 30 degrees, what we would get is the angle that the object rotated, which is 165 degrees. So that's one of my answers. Then they say answer in degrees and radians. So I'm going to show you how we could do the radians in one of two ways. One way, if you're able to easily see this in the degrees, let's convert from degrees to radians. So 165 degrees times pi radians is in 180 degrees. Degrees and degrees would cancel. 165 divided by 180, you would need to type that in on your calculator and reduce it. 165 divided by 180 is 11 over 12. So the answer is 11 pi over 12 radians. Okay, so that's the answer in degrees, that's the answer in radians. In order to show you the math behind, like, let's do the adding, but with radians. So we know that this here is pi over 4, right? Each piece of the pi would be, in here would be pi over 4. This 90 degrees, we know, is pi over 2. And 30 degrees is pi over 6. So if I add those three together, we would have pi over 4 plus pi over 2 plus pi over 6. We need to get common denominators. So the common denominator between a 4, a 2, and a 6 is going to be 12. We need to get a denominator of 12. So I'm going to multiply this by 3 and this by 3. I'm going to multiply this by 6 and this by 6. I'm going to multiply this by 2 and this by 2. Now I have a common denominator of 12. 3 plus 6 is 9, plus 2 is 11 pi's over 12 radians, which corresponds to that answer there. Okay, class example number 5. So again, this one you could do without a graphing calculator, right? I would use a calculator to have gotten this question, but you could have added each of these separately. And so this would be on one of your no calculator quizzes. This would be a fair question. Okay, 2 more class examples to get through for this part. Without using a graphing calculator, it says determine the exact value of the log base 2 cos 7 pi over 4. So what you have to do, Cos 7 pi over 4, you need to find that on your calculator, or sorry, not on your calculator. What is this on your unit circle? So the cos of 7 pi over 4 on our unit circle, here's 7 pi over 4. The cosine is always your x. So the cosine of 7 pi over 4 is root 2 over 2. So this would be log base 2 of the cos of 7 pi over 4 is root 2 over 2. Okay, how could we clean this up? What I hope you could see is both of these are going to be base 2. So let's rewrite this as a fractional exponent. So that would be, I'm just going to write it over here, log base 2 of, the square root of 2 is the same thing as 2 to the power of 1/2, and the denominator is 2 to the power of 1. Log base 2. If you typed in on your calculator 1/2 minus 1, or not even on your calculator, like you should just be able to do that, 1/2 minus 1 is 2 to the negative 1/2. So what we have now is we've got the log base 2 of 2 to the negative 1/2. Use your power law to bring this to the front, and we would have negative 1/2 times log base 2 of 2. And then what is your answer? When your base and your argument are the same, the answer is always 1. Log base 2 of 2 is 1. So negative 1/2 times 1 would give me an answer of negative 1/2. And that's how you do that question. Okay, last class example, and then you could do some homework questions, and then there's going to be one more part for this lesson 5. So this point lies on the unit circle. So again, it's not going to be one of our nice coordinates, but what they want us to find is they want us to find the value of theta. So what we need to do is we need to put this roughly where this is in our unit circle. So if x is negative and y is negative, we are going to be in quadrant 3. So in quadrant 3, that's where this is an x coordinate and that's a y coordinate. Quadrant 3, that's where point A would lie, would be in quadrant 3. Okay, from here, what we could do is a couple of things. We know that this x coordinate corresponds with cos, right? So the cos of theta is equal to negative 0.6157. This coordinate corresponds with sine. So the sine of theta is equal to negative 0.7880. If I said find an angle, all you're doing is you're taking the inverse of cos or you're taking the inverse of sine. It doesn't matter which one we do, we are going to get the exact same angle. So I'll show you. We want to be in degree mode for this question. So if we typed in the inverse cos of the absolute value of that number, which would be 0.6157, what we would get, so let's type this in together. We want to be in degree mode, so I've got to switch over my mode. I'm going to clear this. The inverse cos of negative 0.615, sorry, not negative, we always take the absolute value, of 0.6157. That is going to give us to the nearest, what does it say? They want this to the nearest degree. That's going to give us 52 degrees. And what you have to remember is that is always a reference angle. So whenever you do the inverse cos, inverse sine, inverse tan, the answer is always a reference angle. So let's confirm with this guy. So if we were given sine, and I said, well, what was the angle? You would say, okay, the inverse sine of the absolute value of that number, so 0.7880, is equal to, so second sine of 0.788, 52 degrees. And again, that's always my reference angle. So the reference angle goes in here because remember we could always draw our acute triangle. What they want is the rotational angle. So they want this angle here. So the answer would be 180 degrees. In order to get what theta is, it would be 180 degrees plus your reference angle of 52 degrees. And theta is equal to 232 degrees. And that would be your answer for that.